I'm Julien Serres from Aix-Marseille University, and my talk is entitled Honeybees Flying Over a Mirror Crash Irremediably. It presents research carried out in Marseille, France at the Institute of Movement Sciences, ISM. Flying honeybees are known to be particularly sensitive to optic flow generated by the contrasting features of the tunnel to adjust their altitude. Recently, honeybees were trained to follow the tunnel ceiling while encountering a dorsal ditch midway, from Portelian Colleague Scientific Report 2017. Honeybees coped to this new tunnel's configuration by rising quickly and hugging the new higher ceiling by keeping a similar forward speed, a similar distance to the ceiling, and then a similar dorsal optic flow to those observed during the training step. Conversely, honeybees trained to follow the floor kept on following the floor regardless of the change in the ceiling height by maintaining their ventral optic flow constant. So, our research question is here, can we find an optical context in which honeybees crash irremediably? Let's start with the description of our new experimental setup. We use a flight tunnel put outdoor to work with natural light. The optical context can be manipulated. A mirror on the floor or a mirror on the ceiling can be uncovered by removing the texture on the ground or on the ceiling to impoverish the visual context seen by bees. Honeybees were individually marked with a drop of water-based paint. Each trial was captured with a camera recorder filming the 1.3 first meter at 100 Hz. In the control conditions, all the four surfaces, walls, floor, and ceiling were textured, and bees were individually trained to follow the floor by locating the entrance at about 10 centimeters above the floor. Now you can see a control experiment versus a virtual ventral ditch. This ventral ditch, doubling virtually the tunnel height, was obtained by uncovering the mirror on the floor. This study aims at investigating the role of the dorsal and ventral visual inputs in a honeybee's altitude control by quantitatively reproducing the seminal experiment of Heran Lindauer 1963. In such an experiment, they trained honeybees to fly above a water surface. When the water surface was ripples or when the floating bridge provided a visual contrast, honeybees were able to cross the lake. However, honeybees crossing mirror-smooth water during foraging trips flew lower and lower until drowning. To replicate experimentally such a behavior in a flight tunnel, we use a mirror placed on the floor or a pair of mirrors covered with textures during the training session. Then, mirrors were uncovered, creating a virtual ventral ditch. It was observed repeatedly crashes on the mirror below. We conclude that ventral visual inputs are crucial for altitude control in honeybees. I would like to thank my engineers Marc Boiron, Julien Dipéry, and Patrick Sainton. Thank you for your attention.